Hey guys, today I'm going to be teaching you how to multiply multi-digit numbers using a couple of different strategies. So I'm going to start us off with a 3-digit by 3-digit number because our state standard does say that we need to know how to multiply by 3-digit by 4-digit. So I'm going to start us off a little bit easier, and then I'll give you an example of the 3-digit by 4-digit. And when I say digit, I mean how many place values are in each number. So this one has a ones place, a tens place, and a hundreds place. So that's 1, 2, 3 digits. This one as well has 1, 2, 3 digits. I do teach the standard algorithm because, in my opinion, it's the most efficient way to multiply multi-digit numbers. It's how I learned how to do it in school. It's how a lot of our parents learned how to do it in school, especially with those timed state tests. This strategy really is the quickest way to go, in my opinion. So I tell my students to start with the number with the most digits with standard algorithm, not the one that's bigger, the one that has more digits. So these both have 3, so it doesn't really matter which one goes on top, but I like to keep them in the habit of putting the bigger one on top, so we will do 743 on top. And then 560 down below. Make sure that your ones place, your tens place, and your hundreds place are lined up. With standard algorithm, we always start with the bottom number all the way to the right. So it's just a process. We take this number, multiply it up, over, over. Then we'll move to the next one, multiply it up, over, over, multiply it up, over, over. And then we add those numbers together. So here's what I mean by that. We're going to start with the 0. 0 times 4, 0. 0 times 7, 0. Now that we're done with our first digit, we're going to scooch over to our second digit. So now we have a digit that's in the tens place. So there's something that we need to add before we get started multiplying, and that's going to be a 0. The reason that we put this 0 here as a placeholder is because we want to show that we're multiplying by 60, not just 6. So once we've added our 0, we can go ahead and start multiplying. 6 times 3 is 18. So we can't fit 2 digits down here. We can only fit 1. So if we have a 2-digit answer like 18, then we need to regroup. The 1 will go up top, the 8 will go down below. 6 times 4 is 24, plus 1 is 25. So we will do 2 up top, 5 down below for 25. 6 times 7 is 42, plus the 2 up top is 44. So we will put that. There's nowhere else to regroup to, so they just drop right down. And we're going to put our comma in. So commas go after every 3 from the beginning. 1, 2, 3, comma. Now that we're done with our tens place, we are going to scooch over to our hundreds place. So now we're focusing on the 5. That is our focus number. So I tell my students that every time we switch numbers, there's 2 things that need to happen. We need to get rid of what we've regrouped because that could be confusing if there's a whole bunch of numbers just floating up top. And we need to add our zeros. So because now we're in the hundreds place, we have to add 2 zeros before we start multiplying to show that we are multiplying by 500 and not just 5. And then we just start the process over again. 5 times 3 is 15, 1 up top, 5 down below. 5 times 4 is 20, plus 1 is 21, 2 up top, 1 down below. And then 5 times 7 is 35, plus 2 is 37. Again, there's nowhere to regroup to, so they just drop right down. Comma comes after every 3, 1, 2, 3. And now there's no other numbers. There's nothing in the thousands place over here that we need to move to next. So we are done with this part of it. Now we've got our 1, 2, 3 partial products. And like I said earlier, that just means it's time to add them together. So we always start in the ones place when we're adding. 0 plus 0 plus 0 is 0. 0 plus 8 plus 0 is 8. 0 plus 5 plus 5 is 10. So again, we have to regroup. 1 up top, 0 down below. We can drop down our comma. 1 plus 4 plus 1 is 6. 4 plus 7 is 11. 1 up top, 1 down below. And then 1 plus 3 is 4. So our final product for 560 times 743 is 416,080. Now I'm going to show you how to find the same product for 560 times 743 using partial products. This method is kind of like a stepping stone between standard algorithm and an area model because it is a little bit more broken down than the standard algorithm, but not as broken down as an area model. So the way we set up partial products, I've seen this done several different ways, but this is the way that I teach it. I think that it's the least confusing. I think that it's least all over the place. You're going to set it up the exact same way that we set up standard algorithm. So the bigger value is going to go on top, 743, and 560 down below. The biggest difference that we're going to have here is the amount of partial products that we have. The amount of partial products that we have in this strategy, as well as an area model, is going to depend on what numbers we are multiplying together, how many digits we're multiplying together. So if we are multiplying a 3-digit by a 3-digit number, 3 times 3 is 9, so we should have 9 partial products. So we're still going to start with that bottom number all the way to the right, but instead of just going ahead and multiplying, we're going to break it down by place value and multiply that way. So we're going to multiply 0 times 3 times 40 and times 700. So that's going to be our first group of partial products. Then we are going to move, again, just like standard algorithm, to the next place value. But it's not just a 6 we're multiplying now. It's going to be a 6 in the tens place, so a 60. So we're going to do 60 times a 3 in the ones place would be 60 times 3. 60 times a 4 in the tens place, which would be 40. And then 60 times a 7 in the hundreds place, which would be 700. That's our second group of partial products. Our third and last group of partial products is going to be this 5. So once we're done with the 6, we move to the 5, just like in standard algorithm, except it's not a 5 that we're working with. It's going to be a 5 in the hundreds place, so 500. And just like with the other ones, we're just going to multiply it by 3, 40, and 700. So again, make sure that you've got your 9 partial products, 1, 2, 3, 4, 5, 6, 7, 8, and 9, before you start adding and completely forget something and then have to start all over, because I've done that. So our first partial product is going to be 0 times 3, so 0. The second partial product, 0 times 40, again, 0. 0 times 700, 0. This is where it starts to get tricky, only because this is where I've noticed that numbers seem to jumble up together. I highly recommend using a light pencil, or graph paper works wonderful too if you have some, to just make some lines for each place value. Especially when we start dealing with these zeros, it is very easy for them to get mixed up with each other. And before you know it, you are adding something that's in the hundreds place with something that's in the ones place. So now we've got 60 times 3. And that doesn't mean you need to do it over in the corner. You don't need to add 63 times. All you have to do when you have trailing zeros is multiply the first digits and then add the trailing zeros behind. So 6 times 3 is 18, plus 1 0 would be 180. Again, multiply our first digits. 6 times 4 is 24, plus 2 zeros. Six times 7 is 42, plus 1, 2, 3 zeros. Five times 3 is 15, plus 1, 2 zeros. 5 times 4 is 20, plus 1, 2, 3 zeros. Be careful on this part, because if we have a number like 20, Typically, I see students that want to include the 0 and 20 as one of their trailing zeros, but we need to have 20 and then 3 extra zeros after that. So 4 zeros total, because the 0 and 20 doesn't count as our trailing zeros. And then 500 times 700, 5 times 7 is 35, plus 1, 2, 3, 4 zeros. And once we've got all 9 of our partial products, then we can add them. So we are left with the same product that we got using the standard algorithm, which is 416,080. The last strategy that I want to show you is our area model. This is where I see most of the confusion from, and this is the most broken down way that we can multiply these numbers. We're going to be multiplying by the values, not the digits. So the first step in an area model is to break each one of these numbers down into expanded form, so by their place value. So 5 in the hundreds place is 500, 60 and 0. 7 in the hundreds place, 700, 4 in the tens place, 40, 3 in the ones place is 3. We're going to put one of these values along the top and one of them along the side. So we need to make sure that we have enough room on both sides to fit all of those values in. It really doesn't matter which one goes on top and which one goes on the side, but I have seen where some sections will be bigger than others, but that just correlates to the size of the value. So that would mean that this 500 piece would be much larger than the 60 piece. I'm not going to do it that way because I think that students get too hung up on the size of it rather than solving for it. But it's good to know that that's why some look like that. It's just because of the size of the value. Since this one's right here, I'll go ahead and put him along the top. So 500, 60, 0. And we want to spread it out along the entire area model. This other value is going to go along the side, and we want to put him from top to bottom the entire way. 700, 40, and 3. Now, in between all of our values where our plus signs are, we need to break it up. So we're going to completely chop them down the middle. So here's how we're going to get our partial products. Oh, and you'll notice that with a 3-digit by 3-digit number, 3 times 3 again is 9. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 partial product squares. So setting up an area model seems very difficult, but I promise it's really not. Each box, we're going to look left and up, and those are going to be the two values that we're multiplying together. So for this box right here, it's going to be 700 times 500. This one is going to be 700 times 60, 700 times 0, so on and so forth. In the beginning of the year, when we first start working with these, I do make the kids write them down in each box to keep them organized and get them in the routine of how to fill out an area model. But as time progresses, it's really not necessary. So I'll just do it very quickly. Now it's just multiplying those first digits together and adding those trailing zeros. So 7 times 5 is 35, and we've got 1, 2, 3, 4 zeros behind it. So 35 with 4 zeros. And then the comma is, remember, every 3 in, so 350,000. I'm going to go ahead and fill those out super quick. Now that we've got all of those filled in, we need a little bit of space there on the right, because just like with partial products in the previous strategy that I showed you, we need to add all of these up. My suggestion to my students when doing this is to start with the number with the most digits because that's the one that usually lines up the place values for the rest of the numbers coming below them, which leads to the least amount of errors when adding. Just to keep them straight and make sure that we used every single one of our partial products and didn't miss any, I tell my students, go ahead and check that box off once you've listed it over here to be added. I know that this looks like a lot right here, but I swear I think that this is the part that kids mess up the most on when solving with an area model, just because there's so much going on. There's so many numbers to get confused with. If you need to, draw your lines. It would be a shame to have done all that work just to mess up on the last part. And then we can just go ahead and add. So there you have it. Our final product for the third time for this problem is 416,080. Also, I'm going to bring back our other partial products very quickly, just to compare these two problems together. So this is the area model, and this is where we did partial products. This was something we regrouped. This was something we regrouped. So just take a look at the partial products that we have together. We've got 3 zeros. We've got 3 zeros. We've got 180, 1,500, 2,400, 20,000, 42,000, and 350,000. So we just did the exact same work, just set up differently between these two strategies. I'm going to pump up the difficulty just a little bit and do 4-digit by a 3-digit number, just to make sure that I cover everything that you're going to learn in 5th grade. So this is a beautiful example of the one with the most digits. So this one has 4, this one only has 3, goes on top. We can put 302 down below. So we're back to the standard algorithm. So the quickest, most efficient, in my opinion. Remember that it's just a process. We start with the bottom number all the way to the ones place. And we just multiply up and over each time, and then move to the next digit, do the same, move to the next digit, do the same. So we are starting with a 2 in the ones place. 2 times 8 is 16. 2 times 7 is 14, plus the one we regrouped, 15. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4. So remember that when we're moving to the next place value, we have to get rid of what we regrouped and add our first 0, because we are now in the tens place. We have a 0 here, so all of them are going to be zeros, but we'll keep on the process anyway. 0 times 8 is 0, 0 times 7 is 0, 0 times 1, 0, 0 times 2, 0. There's nothing regrouped to cross out, so we skip that step, moving to our hundreds place. And because we're moving to the hundreds place, we have to add 2 zeros. 3 times 8, 24. 2 up top, 4 down below. 3 times 7, 21, plus 2 is 23. 3 times 1 is 3, plus 2 is 5. And then 3 times 2 is 6. Now we can go ahead and add them together. 6 plus 0 plus 0 is 6. 5 plus 0 plus 0 is 5. 3 plus 0 plus 4, 7. Drop down our comma. 4 plus 0 plus 3, 7. 0 plus 5, 5. And then we drop down the 6. So our final product is 657,756. Now we've got a 4-digit by 3-digit using partial product strategy. So we're going to set it up just like standard algorithm, more digits on top. So if you remember from the previous partial products problem, we're going to multiply by values now. So we're still going to start with this 302, specifically the 2 that we're starting with, but we're multiplying it by the values of each number above it instead of just the digit. So 2 times 8, 2 times 70, 2 times 100, and 2 times 2,000. If you remember what I said in the previous partial products, the way to figure out the number of partial products we're going to have is dependent on what we're multiplying by. So here we've got a 4-digit by a 3-digit. So 4 times 3 would be 12. We should have 12 partial products here that we are adding together. So the next one is going to be the 0. So 0 times 8, 0 times 70, 0 times 100, 0 times 2,000. Now you might be thinking to yourself, if all of them are going to be zeros, because if we multiply by 0, we get 0, do we really need to write them down? No, you don't, but I'm going to, just so you guys have the full picture of what I'm doing. After we're done with our 0, we're going to move to our hundreds place. So we're doing 300 times 8, 300 times 70, 300 times 100, 300 times 2,000. You'll want to just count them up real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I do have 12 partial products, so we can go ahead and start multiplying. And now that we've multiplied all of these together to get our partial products, we can go ahead and add. So you'll notice that our final product is the same thing that we just got with standard algorithm, 657,756. Lastly, I'm going to teach you how to do a 4-digit times a 3-digit number using an area model. So we're going to set up this area model the same way we did our other one. We need to start by breaking both of these numbers into expanded form. This one has 4 digits, so I'm going to put him along the top just because it's typically longer. So a 2 in the thousands place is going to be 2,000. A 1 in the hundreds place is 100. A 7 in the tens place is 70. And then an 8 in the ones place is just 8. Over here, we've got a 3 in the hundreds place, so 300. A 0 in the tens place, so 0. And then a 2 in the ones place is just 2. And then I'm going to start labeling my area model with them. So once we've got all of our numbers along the border, then just like the last area model we did, we split them down the middle whenever you see the plus in between the number values. Again, if you see an area model where this section is way bigger than the sections over here, they're just showing that 2,000 is way bigger than 8 in size comparison. And if you remember from the last area model that we just did, we have to do over and up, over left and up, over left and up. And those are the numbers that we're multiplying together. So now that we've got all 12 of our partial products, you know what we have to do next, and it's adding them up. Especially for the problems that we do that are 4-digit by 3-digit, I really recommend breaking these numbers up by place value with lines or using graph paper. And again, I suggest starting with the number with the most digits because that will line all of the other numbers up. And please check your amount of partial products. We should have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We do have 12. And then we start adding. I will bring back the strategy that we did with partial products. And if you'll see, We have all the same partial products that we did in the last strategy. This one is just set up differently, but we did still get the same final product of 657,756 in 3 different ways.